Welcome to everyone. The paper title is Image Deblurring and Denoising by using a winner filter for different types of noise. I'm presenter of this paper. My name is Dania Amr Jason. Abstract. There are many factors that lead to photographic image deterioration, such as motion blur and geometric distortion. In this paper, a method for image deblurring and image denoising is presented by using an effective linear approach, which is the winner filtering. Initially, two images of paper images and a cameraman image were used as the original image, then blurred and four different types of noise, which are Gaussian noise, salt and pepper noise, speckle noise, and Poisson noise. These noise were applied to the original image to perform noisy blurring image. The image is then removed from blurring and noise by using the winner filter. The results show that the winner filter produces superior results since all of the blur is eliminated. Furthermore, the results show that the winner filter, after denoising, performs better image quality for a blur image and a blur image with Poisson noise than the winner filter after denoising for image with Gaussian noise, speckle noise, and salt and pepper noise, respectively. Also, the image quality parameters, which are peak signal to noise ratio and mean square error, provide greater performance for low SNR. The table shows that peak SNR value, so peak signal to noise ratio value, are increasing while the mean square error values are decreasing, and the values shown in table 1 and 2. Case 1. In the case 1, simulate a motion blur image. In case 1, we take the original image, then add a blur to the original image. After that, we use winner filter to restore the original image. In this case, the winner filter is a perfect inverse filter, where the original image for papers and cameraman image was restored, as shown in figure 1 and figure 2. So in figure 1, we have image, paper image, this original image. After we add blur to the original image, this image, blurred image. After that, we use winner filter to restore the original image, so this restored the blurred image. Also, the second image, which is cameraman image, this original image, then we add blur to the original image, so this image is a blurred image. Then we use winner filter to restore the original image. So first we take two pictures. First image, we take two images. First image is paper image, second image is cameraman image. Then we add a blur to these two images. Then we use winner filter to remove the blur from image and restore the original image. After that, we see that the winner filter is a perfect filter to remove all the blur from image, and this show in figure 1 and figure 2. This case 1, only blur image without noise. In case 2, we take two image which is cameraman image and paper image. Then we add noise. This noise is Gaussian noise. We add Gaussian noise to the blur image, so the picture result is blurred image with Gaussian noise. After that, we use winner filter to restore the original image and remove the blur and the noise which is Gaussian noise from the image, as shown in figure 3 and figure 4. Gaussian noise was applied to the blurred image to produce blurred noisy image. Then we use filter which is winner filter to restore the original image. This code using MATLAB. So after that, figure 3, figure 4 show the original image, blur image with Gaussian noise, and then denoisy image for paper image and cameraman image respectively. Also, in case 3, also we take two image, cameraman image and paper image. Then we add second type of noise which is salt and pepper noise. We add this type of noise which is salt and pepper noise to the blur image. The result image is a blurred image with salt and pepper noise. Then we use winner filter to remove blur with noise from original image to restore the original image. Also, this shown in figure 5 and figure 6. After that, we use the third type of noise, which is speckle noise. Also, we take two pictures as original image, which is paper image and cameraman image. Then we add noise, which is a speckle noise, to the blur image to produce blurred image with speckle noise. Then we applied winner filter to remove the noise with the blur from image, from blur noisy image. And this case also show in figure 7 and figure 8. So we see that winner filter is a perfect filter, which this filter can remove blur and noise from image. In case 5, which is simulate a motion blur image with Poisson noise. In this case, we add noise, which is Poisson noise, to the blur image to produce blur image with Poisson noise. So Poisson noise was applied to the blurred image to generate blurred noisy image. Then winner filter was used to restore the original image. Figure 9, figure 10 show the original image, the blurred image with Poisson noise, also the restored image for papers and cameraman image after using winner filter. In this slide, we show this table, which is table 1. We notice from this table, we show that the value of peak SNR value, which is mean peak signal to noise ratio, and MSE, which is mean square error. The value of PSNR and mean square error for paper image before and after using winner filter for these 5 cases. Case 1, a blur image without any type of noise, only original image add blur to the image to become blur image. Before using winner filter, the value of peak signal to noise ratio is 29 and the value of mean square error is 8.9. But after using winner filter, we show that the value of peak signal to noise ratio increase while the value of mean square error decrease. We show that peak signal to noise ratio value become 92 and the value of mean square error is 0.0045. Also in the second case, which is a blur image with Gaussian noise, the value of peak signal to noise ratio increase while the value of mean square error decrease. Also in the third case, which is a blur image with salt and paper noise, the value of signal to noise ratio increase while the value of mean square error decrease. Also in the 4 case and 5 case, the value of peak signal to noise ratio increase while the value of mean square error decrease. So that means that the winner filter is a perfect filter, so that can remove the noise and the blur image from blurred noisy image to restore the original image. This table is for image, paper image. The same table in the table 2, which is table 2 in this slide. This for cameraman image. Also we show from this table that the value of peak signal to noise ratio increase while the value of mean square error decrease. For example, a blurred image without noise, the value of peak signal to noise ratio is 31. After using winner filter became 55. So the value of peak signal to noise ratio increase and the value of mean square error decrease, become 0.41 after using winner filter. Conclusion of this paper: the results show that the winner filter after denoising perform better and provide the best greatest image quality for blur image and blur image with Poisson noise than the winner filter after denoising for Gaussian noise, speckle noise, and salt and paper noise respectively. Also, traditional method for removing noise from image such as winner filter approach don't eliminate all noise. Thus the enhanced image is still infected with noise. These methods are more efficient if the noise variance is small. This reference, and thank you for attention.